Writing complex loops. Pay close attention to the process here. 3 of them. We'll do this quickly. It's a little tighter. Vertically print all prime numbers between 1 and 100. So what is a prime number? A prime number is a number that's divisible by 1 and itself. Here's how it looks. This loop starts at 2, stops at 100, because when it gets to 100 it stops. So 2 through 99 enters, and I have a Boolean flag, nicely trick. This flag is suggesting that every value coming in is a prime number. I know it's not true. Then I write another loop here that determines if it's not prime, and if it's not, I change the flag to false, such that when I get to the if statement, who is outside this loop but inside this loop, it's going to say if it's prime, print it. Well, let's check how this not prime business works. Divide the number by j, right? I mod j. Divide, see if you get a 0. If you get a 0, it's divisible by another number other than 1 in itself. Why not? Why am I so sure about 1 in itself? Well, because here we're starting at 2, and we are stopping just before, but I shouldn't say stopping, we're stopping at I, which means only the number just before I works in terms of the mod. So any number in between there, if it mods and it gets a 0 remainder, this thing is divisible by some other number, and so it's not prime. I break the loop, this loop stops, comes out. Since it's not prime, it won't print. Neat, nice way of writing this. I'm going to go ahead and run it and check to see if I get my prime numbers at the very end, and there they are, starting with 2, 3, 4. You might say to yourself, wait a minute, I see something here that looks like a mistake. Wouldn't this say 2 is not prime because 2 mod 2 is 0? And the answer is no. Because when I comes in at 2, put a 2 here, j will be 2. Is 2 less than 2? No. So this loop will not run for the value 2. Is prime will still be true, and it would print. I remember something. There's a question that we did before that's very similar to this, and this question was number 12. Look at this. Look at how crazy we wrote this. Look. 2, 3, 5, 7, 11, 13. These were all prime numbers. So we could have written this the way we just did it instead of writing this crazy looking thing. I mean, it worked. All we have to do with the one that we just wrote is to make sure we take care of the double and ints and change where we're stopping. So in essence, much better solution. Change this value to, let's say, 32. Figure out when it's integer versus double. Much better solution. Moving on, number 21. I want to write this guy here, the loop, that's going to add this up and give it a decimal value. This is a byte. So I'm going to say for int I equals 0, I less than binary dot length I plus plus. The length of this is 8 because it's a byte. And now I got to check to see if I can get the values I want. So first thing I want the bit value. So the bit value is going to be the value at a particular spot, integer dot parse int, and that's going to the string we got to put in here. So plus binary dot character at I. So now I find the guy at a position. So 0 first, get the first bit, and I turn that into an integer by simply doing my old trick of concatenating. If I didn't do this, by the way, it would have not worked, okay, because this is not a string, this is a character. So I want to turn it into a string, and I did that. I could have done string that value of as well. The other thing I need to do is the exponent, right, because this is 2 to the 7. So int decimal value is going to be the bit value times math.pow, and we want 2 raised to something. Okay, this is going to be a little tricky. Can I go 7 minus I? Let's see if that works. When I is 0, we'll do 7 minus 0, so it'll be 2 to the 7. That'll be the first bit. Perfect. When I goes plus plus, it'll be 7 minus 1, which is 2 to the 6, and so on. This looks good. I want a place to keep my sum though, so I can't forget my sum here. Can't forget that. Keep the sum going by keep adding on this decimal value. Then we print the sum. Okay. 2 to the 7, 6, 5, so it's 128, 32, 8, 4, and 1. That should give me 173. If I run this, let's see if we get 173 at the end. Yay, it works. Writing complex loops. Moving on. Next one wants to strip off these digits. It's called a digit stripper. Okay, so we're going to go ahead and strip these digits off. First, let's make a number. I'm going to make it 1, 2, 3, 4, 5. So I'm going to say while the number is greater than 0, I'm going to strip off some digits. Digit is equal to number mod 10. Why mod 10? If I divide this by 10, I'll get a remainder of 5. I'll get 1, 2, 3, 4, remainder 5. That 5 is stored as my digit that I stripped off. This last digit. Very common algorithm. The next thing I need to do is I need to update my sum. So let's put the sum back to 0. And let's say sum plus equal the digit. So I just add on the 5 just now. It's the first one that gets stripped off. And then I need to change the number because I need to control my loop. Divide equal 10. Why divide by 10? Because if 1, 2, 3, 4, 5 is divided by 10, you get 1, 2, 3, 4. So in essence, here's what's happening with this algorithm. Take off the 5, add it on to the sum. Reduce the number by 1 digit. So 1, 2, 3, 4, 5 goes to 1, 2, 3, 4. Run it again. 1, 2, 3, 4 comes in. Take off the 4, add it on. Divide by 10. 1, 2, 3. 1, 2, 3 comes in. Take off the 3, add it on. Keep doing that. Eventually, we're going to get to a 1. Add on. 1 divided by 10 is 0. Integer division. 0 is not greater than 0. Loops done. So what I'm going to do, print the sum. And if I print my sum, let's print my sum here and see what I get. Should get me 15. Yay. We are good. 15. We just wrote some loops. This one's a very common one, so you might have really studied this one deeply and pay close attention. It's very common. Primary value, I should say prime numbers, not primary value. Prime numbers are tough. Tough algorithm, but you want to pay attention, really study this one. This is very common as well, finding out the different spots in a string and doing something with them. In this case, we're trying to find a value. And stripping off is very common. That brings us to the end of writing complex loops.